Hi, everyone. I hope you're having a nice weekend. I wanted to, in this announcement, touch base about the respiratory system test and the policies regarding this course because we're coming to an end pretty quickly here. I want to make sure everybody still remembers what we have to do and to hang in there. We're almost done. Um, and I want to talk about the material this week, so I hope you watch this whole announcement because the material that we're covering this week is not covered in lab. Okay, it will definitely go beyond the scope of what's covered in lab, and I have a really strong video playlist to support you in this, but I just wanted to briefly go over that. So as far as the Unit 4 test goes, great job on the test. The class average was 71.39, which is very good. But I did notice on this test that there are more people that missed this test, and I've heard from some of you. I haven't heard from all of you. And as far as policies go, I just want to remind everyone that you do have one makeup test in this course. You have one makeup test, and it's offered before the final exam on May 8th, 9th, and 10th. So anytime during that period, you can go in and take the makeup test, and you can touch base with me about that, and that test will have a 10-point penalty taken off of the grade because of not taking it at the assigned time. So if there is an issue with that, just reach out to me, and I'll make sure to make the makeup test available to you. But really, like by and large, we're doing great in this class. Okay, as far as the homeworks go, the homework is due every Wednesday night, as you know. And some people have missed homeworks here and there. That hasn't been a big problem. But if you do miss a homework, I do accept the late homework for 2 more days. So I take the homework through Friday night for a penalty. After that point, I don't take late homework. So keep that in mind. So moving on from the respiratory system, what we have this week is continuing on with the urinary system. And so I'm not sure how much you have had a chance to look at that because I know we just took the respiratory system test. But last week in class, what we were doing, just as a reminder with the notes, is we were covering the anatomy of the urinary system, and this is covered in lab. So, you should know the regions of the kidneys, the microscopic anatomy of the kidneys, the blood supply to the kidneys, the structure of a nephron. So I mentioned all of this last week in the announcement, the type of nephrons. And so this week in class, what we're doing is we're starting at the bottom of page 4, and we're talking about urine formation. So this is where I would say the difficulty level of this unit goes up and stays higher for the next week. And that's why I wanted to talk a little bit about this material. So just jumping back to Bright Space for a minute. We're in week 12 this week. And in week 12, what you're going to notice is, what I'm saying, that basically we're just continuing on with the urinary system. So we're looking at pages 4 through 8 with the notes. It's deceivingly short. Like I said, please make sure to watch this video playlist a few times. So I made a lot of the videos here, and it goes right along with the book and right along with the notes, but I would go right down this list in order. Overview of urine formation, what is the filtration membrane, what is the net filtration pressure, and so on. So I would watch all of these videos. Some of them are animations from Pearson, and the rest of them I made for you, except for these few at the end. And so basically what we're doing this week is we're talking about urine formation. So the homework that's due this Wednesday is the week 11 homework. And the week 11 homework, just to look at that, that's the one due this Wednesday. That one has to do with the urinary anatomy, but it's pretty straightforward. The homework that has to do with urine formation, the more difficult material, this is not due until next week. So there's another announcement that will come out before this is even due, but I have the link there for you. So getting into that for a few minutes. As far as urine formation goes, I did make a video overview of urine formation, which is very straightforward and very, very important, because if you can put the steps of urine formation into context, then you're going to have a much easier time with this material, because basically, if you understand the steps of urine formation, all I'm doing in the notes this week is I'm expanding on those 3 steps. So I talk all about filtration, and then I talk all about reabsorption, and then I talk about secretion, and then in the end, what is the composition of urine? That's what we're trying to learn this week. Okay, so going back to the overview of urine formation. Just taking a quick look at that. The 3 steps are filtration, reabsorption, and secretion. So you probably are familiar with the fact that our blood is filtered by the kidneys, and the kidneys take waste products out of the blood. And what do you do with those waste products? You're going to produce a product called urine. And so in this picture, and I use this in the video that I made, where you can see blood flowing into, this is the interface between the blood and the nephron. So this is the glomerulus. This is Bowman's capsule surrounding the glomerulus. And this is the site of filtration. So the site of filtration is going to have to be where there's an interface between the blood and the kidney, which is here. This entire structure is what's called the renal corpuscle. I mentioned that last week, and it consists of the glomerulus and Bowman's capsule. And so the first step is filtration, which is indicated by, I would say, like this dark blue arrow, where you're going to have substances in the blood that actually get filtered out of the blood and physically enter into, this is what's called the capsular space of Bowman's capsule. So water and dissolved substances are going to get filtered out of the blood and into the kidney. And filtration in urine formation is literally filtration, just like you know it from any other example, like filtration in a coffee maker. So you have to have a filter, just like the furnace filter or pool filter or coffee filter, and that filter is going to be porous, and it's going to be porous to a certain degree, such that some items are going to be small enough to pass the filter and others won't. And so that's exactly what's happening here at the level of the kidney, that the blood flows through the glomerulus. The blood also flows out of the glomerulus, but when the blood flows through the glomerulus, certain items are going to exit by filtration. And those items, I would call those items the glomerular filtrate. The glomerular filtrate is then going to start going down the renal tubule. And when it goes down the renal tubule, what's going to happen is some of those items are going to be taken back, and some other items are going to be put into the tubule. So switching pictures here for a minute. So, okay, so after filtration takes place, just think of it this way. If filtration is a great process, but it's too simple, because that's like saying, if I pass the blood through a filter, a physical filter, then anything small enough to pass through that filter is a waste product, and anything too big is not a waste product. And of course, that's not true, because some of the small items that pass through the filter and become part of the glomerular filtrate are good items like water and nutrients, electrolytes, that we're going to want to take back. And so that's step 2, right away in the renal tubule, in the proximal convoluted tubule. Much of what got filtered, actually, you can see in red, tubular reabsorption, will get taken back by different mechanisms. That's step 2 in urine production. So I'm going to take back the small items that got filtered just based on size, but it's not really a waste. And then step 3, secretion, what we're going to want to do is take some of the bigger items that remained in the blood. They were too big to be filtered, yet they're wastes. And so you secrete those directly into the renal tubule. And so the net effect of those 3 steps is what's known as urine. And so as far as understanding the more descriptive part of filtration, reabsorption, and secretion, you're going to see that there's lots of rules associated with filtration, and then same thing with reabsorption, but a little bit less, and then secretion, I think, is easiest to understand. So it gets easier and easier, I guess, is what I'm trying to say as you go through these 3 steps. But I'm going to jump over to the notes just to show you that once you get that what those 3 steps are, basically start chipping away at this one step at a time. So first focus on filtration. So you can see in the notes, in order to have filtration, just like we were saying with the coffee filter and pool filter, furnace filter, you have to have a filter, right? And so to have a filter, what it is in the kidney, it's called the filtration membrane. And basically what it is it's part of the capillary wall, and it's right next to a porous layer of the visceral layer of Bowman's capsule. So that's the filter. You're also going to have a driving force. So that's number 2 on my must-have list. You have to have a driving force. And in the case of urine formation, the driving force is going to be pressure. But um, it's not as simple as saying there's one pressure that's going to drive filtration. There are actually four pressures at play. And what you do to understand those is you look at the sum of all four of those, which is known as the net filtration pressure. And I did make a video about this, and in your notes, what I tried to do is I tried to summarize this by showing you there are two pressures at work. There's going to be a hydrostatic pressure or water pressure, and then there's an osmotic pressure or an attraction of water to move into a concentrated area. And so those two pressures are at work both inside of the glomerulus and in that capsular space of Bowman's capsule. And so before you get too nervous about this, I did make a video explaining this really, I think, clearly, but if not, please contact me. So the main driving force of filtration is the blood pressure inside of the glomerulus. That's the main driving force, and that's going to be the biggest positive number in this equation compared to the hydrostatic pressure of Bowman's capsule. There is a hydrostatic pressure of Bowman's capsule because as the filtrate enters into Bowman's capsule, you can imagine you can only get so much filtrate in there, and then it kind of pushes back. And so that's a small negative force that's going to prevent the full strength of the hydrostatic pressure inside of the glomerulus entering into Bowman's capsule. There's also the issue of osmotic pressure, like I said, the attraction of water to move into a concentrated area. And in Bowman's capsule, you know, this theoretically should be zero, and so in our book they just dropped this out of the equation. That's because there are no proteins that get filtered, and so water's not going to be osmotically attracted into Bowman's capsule. It's going to get pushed out by hydrostatic pressure. But because it is very watery, the solution that goes into Bowman's capsule, some of that water is going to be attracted to go back into the blood. That's what's called the glomerular plasma osmotic pressure. That's a force that resists filtration a little bit. And so, like I said, you should really look at these four individual pressures, understand those, and understand how to come up with the net filtration pressure, which is an equation. But the way I explain it in the video and the way I talk about it in the notes, I'm hoping that you don't have to memorize an equation, that you can literally just, know which factors are positive and which factors are negative. And as an example, in this picture, they're giving you values for each of the three existing factors in the net filtration pressure. And if you know which forces oppose filtration, all you have to do is put a negative sign to those and a positive sign to the force that drives filtration. So for example, we know that the blood pressure in the glomerulus drives filtration. That's a positive 55. These other two forces oppose filtration. So positive 55 minus 30 would give you positive 25, minus 15 would give you positive 10. So even without the equation, you can see how I was able to figure out that net filtration pressure. So again, that's something that you're going to have to look at a few times to get it, but it's not hard and you will get it. And if you have problems with it, reach out to me and I'm going to help you out with that. So once you get through, the factors that go into the net filtration pressure, you should understand that we need to filter wastes out of our blood at a certain rate because we produce them at a certain rate. And if you don't filter those wastes out at a certain rate, then you become toxic. And so that threatens life. And because of that, we regulate the glomerular filtration rate. And you should understand how we regulate the glomerular filtration rate. One way is we can adjust the diameters of the afferent and efferent arterioles, which will change that hydrostatic pressure inside of the glomerulus. And the other way is hormonal. And we've talked about the renin-angiotensin mechanism before in this class. That comes back. And so here what you need to do is you need to understand where the renin is coming from. This area called the juxtaglomerular apparatus, which is which I explain, in this video of the glomerular filtration rate. It's just basically taking a look at a picture from our book. It's the distal convoluted tubule, the macula densa, some specialized cells in the distal convoluted tubule, and some smooth muscle cells in the afferent arteriole together make up what's known as the juxtaglomerular apparatus. And so this is where the blood pressure is being monitored in the kidney when we talked about that before. It's in the afferent arteriole. And this is also where renin and erythropoietin can be released, this region called the juxtaglomerular apparatus. So I want to make sure that you remember that. And then in the notes, I also gave some pictures that go with that. And unfortunately, they're not right there. I need to reposition those. So there are some pictures there that might help you out. And then I talk about what is, the filtrate. And then I go into reabsorption, what gets reabsorbed and how does it get reabsorbed. That's basically what I'm talking about here. Small nutrients get reabsorbed, glucose by active transport, amino acids by active transport. Just to contrast that, proteins are not reabsorbed. They're too large, but single amino acids, sure. Sodium is reabsorbed by active transport, and that creates a positive charge, which is going to passively attract negatively charged ions. And then water, of course, is passively reabsorbed. Knowing what happens in the countercurrent mechanism at the loop of Henle, you should take a look at that, and I made a video about that. And then what gets secreted, finally giving us urine. So there's a lot this week, and like I said, I think the best thing that you can do to really learn this week is go through that video playlist a few times while you're looking at your notes. And I think you'll see how this works. And if you don't, like I said, I would love to help out with that. So have a great week, and I'll hear from you soon with questions. Thank you so much.